Hi, we're Group 7, and we did the evolutionary approaches to blackjack. So we chose a problem that we decided we could use evolutionary computation for, and we ended up using multiple different evolutionary approaches to solve this blackjack game. And start out, we decided that we had to program the game and determine what inputs we needed and what outputs we needed so that we could find the optimization to actually win blackjack more often than not, using different evolutionary approaches. So the whole purpose of using the evolutionary approaches is that they're good at optimizing functions that don't have easily calculable derivatives or gradient descents or anything like that, which blackjack is that game exactly. It uses decision matrices to kind of determine how you want to play the game. So we went about using these different evolutionary approaches to try to optimize the game. So we each created a different agent. I created a genetic mutation agent, which basically just randomizes a decision matrix, trying to figure out how to play blackjack the best, and it ended up doing pretty well. And everybody else kind of took a slightly different approach, which we'll go over right now.
So I implemented the particle swarm optimization strategy to produce a strategy matrix to play blackjack. So I had a few different particles set randomly within the search space for playing blackjack, and as training went on, they were optimized. And so training was a bit unstable, but it did produce a matrix that worked fairly well.
So my work about the blackjack player agents is to use ant colony optimization. The card that players want to draw is like the food that the ants want to go to find. The agent has a motivation to draw the different cards and different card values, has different weights. Then the agent will calculate the preference to each card. This helps to calculate the possibility to go into hit it. But however, choosing to hit has the risk and also the return. So the agent will calculate the risk and return to to maximize the return and minimize the risk. Then this will be the criteria for the agent to calculate which is the best possibility to go to the hit. Sorry.
Hi, so I'm using ant colony optimization based neural network training. So I'm going to, first of all, so basically in that what I'm doing is getting the particular optimized weight for the neural network, and I have used 2 to 4 to 1 neural network, and in that based on the ant colony optimization, it gave me very very optimized good weight. Based on that, once I train my neural network, I use that neural network to select the strategy, whether on particular cards of player and the dealer card, what strategy should I use? Should I use hit or stand? So that will decide my neural network. I'll give the input as a player point and dealer point, and based on that my neural network will decide whether should it be hit or stand. So that's what I have done for this problem.
And then the final approach that our group took was more of a diverse evolutionary computation approach, which was kind of a mixture of a lot of things, but mainly it involved crossover of the decision matrices and keeping parameters constrained that ensured diversity, but also slowed the speed. So as you can see, we had many different approaches for evolutionary computation, including swarm and colony optimization, genetic mutation, and then diverse approaches. But the whole point of everything was to optimize a black box problem, which they all did fairly well. And from the comparison, we determined that there wasn't necessarily a best approach, which was kind of a shocking conclusion. But ultimately, the algorithm required in terms of which evolutionary computation algorithm actually does the best kind of really just depends on the complexity of the problem at hand. So that was our report. That was the problem we solved, and we're Group 7 evolutionary approaches to blackjack.